Okay, it's now time for part 2 of our writing a rule that represents the following function of our quiz 5. So here's our question. We're going to write a rule that represents this function. And remember, I thought you guys went, well, this was a little sneaky. So from 12 to 9 is a plus of 7. That's correct. From 9 to 26 is a plus of 7. And from 26 to 33 is a plus of 7. Why did I write 3? I don't know. Is a plus of 7. From 5 to 10 is a 5, plus of 5. 10 to 15 is a plus of 5. And 15 to 20 is a plus of 5. This was a tricky one. I thought that would be the answer, and it's not, because it doesn't have a slope of 7 over 5. How did I get that? If this is your y and this is your x, slope is defined as y over x. Changes in y over the changes in x. My changes in y was plus 7. And because it's a plus 7, we know it's not an exponential function. If it was exponential, it would be times 7. So since it's a plus 7, we know that it's a arithmetic or a linear equation. But my changes in x's are plus 5. So that means the changes in y over the changes in x would be 7 over 5. So that eliminates all of these, especially the exponential functions. Our correct answer is 7 over 5x plus 7. How did I get the plus 7? Well, if I took this up, if I one more, I would get 0 here, and I'm sorry, not 7, it's 5. I apologize. I would get 0 here and 5 here. So our y-intercept is 5. So the equation is 7 over 5x, which is our slope, plus 5. Hey, this is a linear equation. You tricked me. I thought we were talking about exponents. With the next equation, which of the following statements correctly compares the graphs below? Let's see. The purple graph rate of change always, I'm really careful with these words like always, is always greater than the blue graph of change. Well, it's not always. If you start here, purple is ahead. But once you get to this point here, purple then becomes behind because blue is closer to the y-axis. So we know that this one is not correct. The blue graph will eventually exceed the rate of change for the purple. Well, here's the blue graph. And it's losing here, but here's where the transition happens, and the blue is closer to the y-axis, which means the rate of change is faster. So this is correct. But let's go ahead and go through the others just so we can make sure there isn't a better answer. The purple graph is never greater than the blue graph. Well, that's not true. The purple graph is greater at this point here. Purple is greater, and it's because it's closer to the y. So we know that's not correct. Be careful of those always and nevers. There is not enough information to compare the rate of change of the blue and orange graphs. Well, there isn't even an orange graph, so we know that this is not correct. Somebody tried to trick us. The correct answer is the blue graph will eventually exceed the rate of change of the purple. Exponential functions will eventually there's no I in exponential. Will eventually outbeat a linear equation or a linear graph. Great job, everyone. Okay, we are now going to write systems of inequalities for the graph that we see here. These are a little difficult, but we're going to refresh our memory and use our information from writing linear equations. So when we're writing linear equations, we use the slope-intercept form of y equals mx plus b. In this case, there's one of four options it's going to be. Y is less than mx plus b. Y is greater than mx plus b. Y is less than or equal to mx plus b. Or y is greater than or equal to mx plus b. We have to write this for these two lines here for this equation. The first thing we're going to do is, the easiest way to start this is to find your y-intercepts. So for this first solid line, my y-intercept is 4. So the b for graph 1 is 4. We're now going to find the m, or the slope. The slope of that line, I would pick another point. To find the slope of that line, I would pick any other point that's on the solid line and move towards that. Starting with moving up or down, then left and right. So starting from point 4, 0, 4, I'm going to move 1, 2, 2 down. And then I'm going to move to the right. 1, 2, 2 to the right. A downward movement means it's going to be negative, so it's going to be a negative 2. And then a right movement is a positive, plus 2. To simplify that, negative 2 divided by positive 2 is negative 1. And since this line is going down, it's a negative correlation. So yes, the slope should be a negative 1. Now, I need to decide whether it's going to be less, greater than, greater than, equal to, or less than or equal to. The way I do that, less than means down. So looking at the y-intercept, clear that up. Y-intercept being 4, this graph is shaded this direction, that's down. So it's either this one, So it's either this one or this one. The only way I know that it's the only way I know if it has this equal to or not, if the line is solid. And because this line is solid and not dashed, I know that it's going to be that symbol there. So this is going to be less than or equal to. Now let's get the components of the other equation. And because it's the other equation, I'm going to choose a different color. I'm going to choose black. The first thing we need to find is the y-intercept, or the b. The y-intercept for the second equation is negative 2. I'm going to pick another point on this line, and I can pick any point I want to. So I'm going to pick that one. And let's count the movements. We move up, down first, then left, right. So from negative 2 to this positive, from 0, negative 2 to 2, 0, I'm going to move up 2 and right 2. Those are two positive movements. So my slope would be positive 2 over positive 2, which would give me a positive 1. Now I need to decide which way is this graph being shaded. Well, here's my y-intercept, negative 2. Just because that's a negative 2 doesn't mean it's shaded down. It's actually being shaded up above that line. So up is either greater than or equal to. The alligator should be eating the y and not the equation. In this case, it's going to be greater than, because the solutions will not include anything on this line. So that's why it's dotted. It's dotted because none of the answers are on that line. That line is actually a boundary. So that's the correct symbol. Now we can write our equations. Still wrote equal. Sorry. I wrote the equal and I listening. So here are our two equations. Wow, that was a little tough, but we got through that. Great job, everyone. Now we're going to, I think we need to do that one again. Let's try another graph. We're going to write a system of inequalities for this one as well. First thing is, find our y-intercept. Then pick another point on that line and move towards it to find the slope. That was up 2, right 2. And 2 over 2 is 1. Now, you need to decide whether it's shading above or below. In this case, it's above the line. And that means greater. Up means greater. The alligator should be eating the Y. Is that line solid? Yep, that means it's greater than or equal to. So we got all the components for the first equation. Now let's do it for the second line. The second equation for the second line. What's our y-intercept for the dotted line? Yep, you guessed it. It's -1. Now we're going to pick another point on that dotted line and move towards it. This time we're going to go down 2 and right 2. So our slope would be -2 over +2, which is -1. Is that a solid or a dotted line? Well, that's a dotted line. So we know it's not going to be equal to. And is the equation shaded above this line or below it? That is definitely in the upward movement. So that means it's greater than. So let's write our two equations. Here are our two equations for this graph we're looking at. What a great job. Thank you for your hard work. Want to try one more? Yep. Let me give you a moment to try this all by yourself. Go ahead and hit pause and try writing that system of inequalities. Okay, did you get what I got? How awesome! Let's just go through and explain this very quickly. Here is our y-intercept here is a +2. Don't let the 1s and 3 confuse you. We just moved up 1 and left 3. That's why the 3 is negative. So here's our slope, which is right here in our equation. Our y-intercept is +2. For the other equation, we moved up 2 and right 1. Here's our slope for that equation. 2 over 1 reduces to 2. But unfortunately, we're down to -3. I'm sorry, I put 2. Did you catch that?